All right, how do we graph these absolute value transformations? For things of the form a times the absolute value of x minus h plus k, we're going to follow these steps. We're going to plot the vertex. We're going to plot the axis of symmetry, which just goes right through that h. And then we're going to use a, this number right here, to determine the slope and the direction. If a is greater than 0, the graph will open up, and if a is less than 0, it'll open down. And because these are very connected to linear functions, a just behaves as a slope, both positive and negative slopes, though, to make these v's. A will also behave as the slope of the right-hand side of your graph, and then you can just reflect that over the axis of symmetry. Whenever we were talking about general functions, we kept using a, b, c, and d, whereas here we've been using h and k. Well, d and k, these are always the exact same thing. And most of the time, c and h are the same thing, but not always. If there is a b, you have to factor out b in order to see the h. And it's important that we are able to see h because remember that hk is the vertex. So again, here's that just written out. If there is a b, if there's a horizontal dilation, you have to factor out b to find the vertex. And then whenever you're graphing these, all of the x values will be divided by b, just like we've seen before. All right, let's start by just graphing the parent function, y equals the absolute value of x. Here I made a table of some x values, and then the y's would just equal the absolute value of those numbers. So fill in this table. As you can see, the positive numbers stay the same, and the negative numbers turn positive. Because we don't see an h and k, that's noticeable here on the graph because the vertex is here at 0, 0. And then just plot these points. Negative 2, positive 2, negative 1, 1, 1, 1, 2, 2. So what we have here is basically a line that had a slope of 1, but whenever the y's wanted to go negative, it just bounced right back up into the positive because it's an absolute value. And an absolute value sign makes whatever's inside positive. So again, the parent function has a vertex at 0, 0, and its axis of symmetry is x equals 0, this invisible line right here. All right, so now let's start applying some transformations. Y equals absolute value of x minus 3 minus 5. From transformations, we should see that this is probably going to move right 3 and down 5. Well, what are h and k? We remember that we always take the opposite of this number, so the vertex is at 3, negative 5. And go ahead and plot that point. The axis of symmetry is just x equals h, so my axis of symmetry will be x equals 3. So you draw a dashed line through x equals 3. The direction, because this is a positive graph, it's going to face up. Figuring out the slope of this graph, we can see a is just 1. So it'll behave to the right as if it just has a slope of 1, and to the left as negative 1. So to the right, I'm just going up 1 over 1, up 1 over 1. And then to make my V shape, I'll just mirror that over the axis of symmetry and connect my dots. Alright, see if you can determine the vertex, the axis of symmetry, and direction just from looking right up here. I'll give you a moment. Alright, so we should have the vertex at 4, 6. The axis of symmetry is x equals 4, and the direction is down because this is negative. Alright, so the slopes, since this is facing down on the right-hand side, since this is negative 1, this will have a slope of negative 1, and then we'll just mirror it on the other side. So you should start by plotting the vertex and drawing the axis of symmetry. And then from that point, use your slope of negative 1 to draw a few points to the right, and mirror those points. And there you have it. There's your absolute value graph. Alright, now I have a 3 out here in the front. So how is that going to change the graph? Is it going to make it wider or more narrow? Well, let's look. First of all, the vertex we can see is at negative 2, negative 4, putting our axis of symmetry at x equals negative 2. So let's go ahead and plot that. Because the 3 out in the front is positive, it's going to open up, and the right-hand side of this graph will have a slope of positive 3. Or we can think about it as 3 over 1, because every single point you're going to go up 3 and over 1. So make sure you draw at least 2 points per side, then mirror them over the axis of symmetry until we have a nice graph. So we see that the 3 made our graph more narrow because this was a vertical stretch. If this was a 1/3, it would have been wider because that's vertical compression, just like you've seen before. Let's take a look at y equals the absolute value of 1/2 x. As you can see, there's no h and k. There's nothing being added to the x on the inside or the outside. So my vertex is at 0, 0, putting the axis of symmetry at x equals 0. Now, because this is still positive, the direction is still up, but the slope changes here. So because this is of the form y equals bx, all of the x values have to be divided by 1/2, which is the same thing as multiplying those x's by 2. So normally with this slope of 1, you'd have the points 1, 1 and 2, 2, but all of the x values get doubled now because dividing by 1/2 is the same thing as doubling. So 1, 1 becomes 2, 1, and 2, 2 becomes 4, 2. And then we just mirror that on the other side. This was a horizontal stretch. All right, here we have this 2 is inside of the absolute value. So remember, before we even start, I need to factor out this 2, leaving me with x plus 3 minus 1. All right, and that's going to help us identify the vertex, which is now at -3, -1, putting my axis of symmetry at x equals -3. It's a positive graph, so it's going to open up. This slope will act as just 1 because that's all we have on the outside. But then remember, so here let me zoom in a little bit. What we're going to do is we're going to plot these as if we had a slope of 1, but then the x distances are going to be divided by 2. So instead of having to take a whole step to go up 1, it only takes half of a step. And instead of taking 2 steps, now it only takes 1 step. We mirror that on the other side, and we have a horizontal compression. Wow. If you're graphing on a specified domain, reminder that this domain is just certain points. It's not continuous. So all we really have to do is plug each of these numbers in and form a graph. So if I plug in 0, I get 0 minus 2 is -2. The absolute value of -2 is positive 2. 1 minus 2 is -1. Absolute value of -1 is 1. And so on and so forth. Until you can fill out your table, and now we're just going to plot these points. 0, 2, 1, 1, 2, 0, 3, 1, 4, 2. That's all we're going to graph. We're not going to connect these points because this is a discrete domain. And look, it even looks just like you would expect. It looks like an absolute value graph that's been shifted to the right too. All right, and that's everything. Goodbye.